All right, hi, still looking at like harder trig here, and we're going to look at law of cosines. Law of cosines is useful when you know usually either all three sides and no angles, or you know two sides and the angle that's not corresponding to one of those two. So like with law of sines, because we know angle C, we would also want side length C, and we don't have that. So we can't use law of sines on this problem. There are three versions of law of cosines, but I tried to emphasize to you all to think of it as like the Pythagorean theorem, but with this extra bit that sort of takes care of the fact that it's not actually a right triangle for us. And I also pointed out to you or told you that, if angle C is 90 degrees, this part would become zero and go away, and it would just be the Pythagorean theorem. So actually the Pythagorean theorem is just a specific version of the law of cosines. Humans figured out the Pythagorean theorem first, and then after a long, long time managed to actually say, well, this is how it works when it's not a right triangle. They didn't have to be as specific anymore. So on this one, we know angle C is 30, this example, we know that angle C is 37 degrees. We know that side length A is 8 and B is 11. So we're going to use this top version of law of cosines, and we don't know C, so C squared, we don't know side length C, C squared equals 8 squared plus 11 squared minus 2 times, okay, these two numbers, A and B, 8 and 11. That's my cat having a good time. Look at it. Go crazy. If you own a cat, you know that no one actually owns cats and they just do random stuff like that. B is 11. And then cosine of 37 degrees. Okay, so from there we're going to crunch some numbers on the calculator. C is the only variable, notice. So C squared is 64 plus 121. Let's see, 8 times 11 is 88, times 2 is 160, 16, 176, minus 176. But cosine of 37 degrees, I will need a calculator. Make sure you're in degrees. Make sure you punch cosine, and it's 0.7986. Roughly. So I'm going to multiply that decimal on my screen by 176, and you get about 140.56 if you just do two decimal places. So 64 plus 121 minus 140.56. And we've estimated, really that's wavy equals, approximately equals now. The grand total here, 64 plus 121 minus the ugly decimal on my screen, is about 44.44. So C squared is approximately 44.44. You would then take the square root of both sides, and square root of 36 is 6, square root of 7 is 49. So I'm expecting C to be a decimal somewhere in the vicinity of 6 point something, closer to 7. And if I do the square root, you should get about 6.67. and that would be the third length that we didn't know. Why is that helpful? Well, we didn't know it, now we do. But also, now that we've worked a law of cosines problem to find the side, if we need to, like if the problem asks us to solve the triangle or it starts asking for other things, after we finish all of this, we can, we can say, well, measure of angle C was 37, A was 8, B was 11, C was about 6.67. By the way, I didn't draw a triangle. Sorry. If you needed the triangle, there's no shame in drawing a triangle to help you think. We could now, if we needed more information about the triangle, we can now use the law of sines to figure out whatever it is we want. Let's say that we also needed angle A or angle B or both. We're going to use law of sines to find one of the angles, and then use the fact that the three angles in the triangle make 180 to find the other angle. So let's say that we decide we're going to find the measure of angle A. Oop. Well, we know that sine of A compared to little a is equal to, well, now we know angle C and side length C. So we'll use that version of law of sines that uses the A's and the C's, and we'll fill in the things we know. We don't know angle A, we're trying to figure it out. But we know that side length of A is 8. And again, this is going to be approximately equals because we've estimated this number. Sine of 37 degrees in ratio to 6.67. Because 6.67 is just a little less than 8, that means that angle A is going to be, in the vicinity of 37 degrees, but not quite. So we're going to, with the assistance of a calculator, we're going to check what sine of 37 degrees is. We're going to get that sine of A is to 8 as 0.6018 is to 6.67. That decimal that's on my screen divided by 6.67 is, not a very big number. It's 0.0902. We would multiply that by 8. So I'm just going to multiply the decimal on my screen by 8. And when you multiply it by 8, it's 0.7218. And we know the ratio, we're trying to figure out the angle. So it's going to be a calculator lookup using inverse sine. And because this is between -1 and 1, it exists. We're going to get an answer. So inverse sine of that decimal is to the nearest tenth, and one decimal place is 46.2 degrees. which means that the other angle, which would be angle B, we could still do law of sines or law of cosines, but that's a lot of work. Instead, we'll just use that the triangle's 180, but we know that C is 37, and we've just figured out that A is 46.2. So that means that angle B would have to be 96.8 degrees, or else it wouldn't make a triangle. And so the law of cosines problem, if you only need to find like one missing thing, maybe you can be done. But if you need to find more than that, you can usually switch to using law of sines, because a lot of people think law of sines is easier or less work. And we figured out that A, with this work, was 46.2 degrees, and that got us that B would have to be 96.8. And at that point, we were given angle C, we figured out angles A and B, we were given side lengths A and B, and we figured out, using law of cosines, side length C. So there's an example, or another example, because there are several in MyLabs Plus of law of cosines, and we'll probably also do one together. I can do one more actually. Let's do one where you don't know any of the angles. Let's show you that this does work when you know three sides. So if you think you've got it, maybe you don't need this, but just in case, I wouldn't want to leave you feeling like you still need a little more. What if you just know three side lengths? What if you have a triangle and you know that A is 9, B is 5, C is 8? Well, you don't have to do this, but I would recommend it. The first thing to do is realize that this can make a triangle. And this can make a triangle because the shorter two sides, 5 and 8, when you add them together, is more than the longest side of 9. So that means it is a triangle. I don't know that there were any on MyLabs Plus where it wouldn't be a triangle, and there is the no solution problems for the law of sines, but for the law of cosines problems, I don't know if there are anywhere they ask you to figure out, well, what would the angles of this triangle be? And it's a cheater question where there actually aren't angles because it's not a triangle. But it's good practice to check that the smaller two lengths with the together are more than the longest length, because that's how to guarantee that it's a triangle. Again, that's called the triangle inequality theorem. You might have seen it in high school geometry. So we'll just use the version of law of cosines that we think looks like the Pythagorean theorem. So again, it's A and B here, so it's A and B here. It was side length C over here, so it's cosine of angle C right here. And we don't know this. That's going to be what we figure out. We're going to figure out angle C. And once we know angle C, we could use law of sines to find angle B. And once we know angle C and angle B, we could just use the three angles in a triangle make 180. So it's law of cosines is kind of the most work. And then law of sines is a little bit less work than that. And then by the time you use that to find two answers, finding the third answer, the third angle, isn't going to be much work at all. So with these labeled the way they are, C would be 8 squared, A would be 9 squared, and B would be 5 squared. Again, it no longer matters that the longest side's over here by itself because it's not Pythagorean theorem. Minus 2 times AB is 9 times 5. For right now, we're just going to treat cosine C like a variable. We don't know what it is. 8 squared is 64. 9 squared is 81. 5 squared is 25. 9 times 5 is 45. 45 times 2 is 90. So minus 90 times cosine of some angle we don't know yet. 81 and 25 is 106. So 64 is 106. Subtract 90 minus cosine of some angle. So kind of the idea here is that cosine of C is going to be between -1 and +1. And it's a decimal. And so when it's going to change the 90 to some fractional part of 90, it might change the sign if it's negative. And it's going to make the math work out that 106 minus this number is going to be 64. So you could subtract 106 on both sides. And you'll get 42. I believe it'll be -42, but it's also kind of late, and I hesitated, so I should probably check it because it would feel real bad. Yeah, it's -42. It would feel real bad to work the whole problem and then realize that you had done that arithmetic error. Is -90 times cosine of C. And then so this is being multiplied, so you'll divide by -90 to work backwards. And it turns out the negatives are going to cancel. And so we're sitting at cosine of some angle is the ratio 42 to 90. So to find angle C, we got to tell the calculator, hey, look up the angle that has a cosine of 42 out of 90. Use inverse cosine of 42 out of 90, or whatever 42 out of 90 is, on a calculator. If you use 42 out of 90, make sure that's 42 over 90 or 42 divided by 90 in parentheses. So you got to be careful how you key it. It varies slightly from calculator to calculator. And always make sure you're in degrees, unless we're working a problem in radians, which we won't do with these. 62 point to the nearest 10th, 62.2 degrees. 62.2 degrees. So we've used the law of cosines. Oop. It's weird that it's flashing the embedded camera image when I click on options from the drawing menu. That's weird to me. See, it's going light and dark. I don't know how obnoxious that'll be on the video, but I'm not sure why it's doing it. If we needed to know all three angles, we would use the information that we just had. B was, I feel like B was 5 and C was 8. Yep. Again, I'm sorry that this is flashing or whatever for you all. That's probably going to be annoying. And we figured out that angle C was approximately 62.2 degrees. If you needed one decimal place. If we needed two decimal places, we would use 1/8. So we can use law of sines because we know angle C and side length C to find either A or B. So let's say that we're going to use sine of C is to side length C as sine of A is to side length A. So sine of 62.2 degrees in ratio to 8 is going to be approximately equal to, because again, these are some rounded numbers, so we don't know that it's not exactly equal, but it's close enough because it's a rounding. We don't know angle A. We're going to figure it out using sine, not 8. Boop. Why is the undo not working? There it goes. A is 9. So because the 8 and the 9 are almost the same, angle A is almost probably the same as the 62.2 degrees. It's going to be a little different. So we use sine of 62.2 on our calculator, and you get 0.8846, rounding to 4 decimal places, because I always like to go a few extra and then dial it back when I write a final answer, is to 8 as sine of the angle we don't know is to 9. And so we divide that decimal by 8, and we get approximately 1106. And we multiply the 9 over, and we get 0.9952. For sine of A. We know the ratio, we want the angle, so it's an inverse sine problem. Make sure you're in degrees and have your calculator look up the angle that would have a sine of 9952, or the decimal on your screen if you've been careful and can manipulate it. And you should, to the nearest tenth of a degree, get 84.4. So now we know that angle A is 84.4. So angle B, what would we have to put with those two angles to get to 180? 180, subtract 84.4 and 62.2 is 33.4. So you could build a triangle that has side lengths of 5, 8, and 9. And when you get that sucker built, these should be pretty close to the angles you would measure for the three angles. And again, notice that the shortest side, B, is across from the smallest angle. The longest side, A, is across from the largest angle. That's actually also a good way to just, you're not 100% sure you're right, but it should make sense that, long sides are across from large angles. Short sides are across from small angles. That's a good basic fact about triangles from high school geometry that's probably helpful to keep in mind sometimes when you're looking at these harder problems. All right, so that's some law of cosines problems. And again, we'll start class with some extra, because I know that not everyone will even see these. So if you have seen them, I hope they helped. If not, we'll do some similar problems to start class. But you have these videos as reference. All right, well, thank you for your time.